next speaker is Richard Hillis, speaking for the DETCRC. And the title of the talk is A Technology-Enabled Revolution in Mineral Exploration, Prospecting, Drilling. Richard?
Thanks. Thanks very much. Yep, we're good there. Yeah, look, I'll try and think what bits of this puzzle I should cover that haven't been covered so well by James and Aaron and Steve. So I'll just go on the fly and try and fill in the pieces of the puzzle that haven't been well explained. But the DETCRC has been a terrific journey, and for those who don't know, we had over $60 million to spend and $150 million cash in kind, thanks to sponsors who stuck with us through a pretty significant downturn in the mining industry. So I never apologize, even in a 10-minute talk, for thanking those sponsors. And as you can see from the logos there, it's a pretty significant collaboration. Here's really what I'm trying to argue, and I think given the terrific job from the earlier speakers, it's a straightforward job. We've tried to principally develop three pieces of technology that we think will take us from bump drilling, I'm going to jump on Steve's terminology, to prospecting drilling, for the cost of one diamond hole on a geophysical anomaly, be able to drill half a dozen holes with the kind of real-time data that James and Aaron have described, and real-time analysis that permit multiple holes in the same program without demobilization and remobilization to vector towards deposits. So it's trying to bring it all together. It's a lot to bring together. All we, as the DETCRC, have done is develop working prototypes of some of the pieces of the puzzle, and folks like Reflex are taking them to commercial products. Folks like Boart Longyear are taking them to commercial products. So the three pieces of the puzzle we think that can be a revolution in exploration are cheaper drilling, 6 holes for the price of 1, real-time downhole petrophysics, and near real-time geochemistry and mineralogy, within a shift such that the next shift has those results of petrophysics and geochemistry and mineralogy. I better keep going. I can only give you a flavor of the technologies. We have licensed to Boart Longyear a downhole platform for getting gamma magnetic susceptibility and galvanic resistivity without a separate wireline mobilization. This is a tool deployed by the driller. It recovers the data. It's put inside the drill rods. It recovers the data when the rods are pulled and gives us routine petrophysics. And James mentioned a different product. I think it's all fathered by the same thinking. Reflex of a product for near real-time gamma. It's coming. Whichever products, and doubtless down the line there'll be other products, what we are going to get is multi-channel routine petrophysical data. And there's a lot of geophysicists at this conference. We're going to start to address that challenge of linking the geophysics to geology, because we will have hitherto unforeseen databases of rock physical properties that will just be routinely churned out. So that's critical, and I said a little bit more about that because I think the lab at RIG has been better covered by James and Aaron, so I don't feel the need to say that too much, but the technology that we were part of developing has been about real-time data from diamond cuttings. That in itself is invaluable in terms of the cycle of exploration, as James said earlier. But for us, it is also a critical tool towards cold chipping drilling, because while it is 6 times cheaper than diamond, it won't return a core. But I believe, and I'm happy to be assaulted about it later, I believe that as a community, we will settle for drilling that is 6 times cheaper, that has routine mag-sus, density, natural gamma, geochemistry, mineralogy that is routine, correct, and objective over the ability of a diamond drill core, which we can go and collect when we need to, when there is real textural information that can only be resolved with drill core. There's the broad positives of coiled tubing drilling. I think I'll let you read them rather than try and work through them. But the drill string is a continuous coil. We're not stopping to connect rods. It is much quicker. It is also much safer because there is no manual handling of pipe. And there are other advantages. Routinely, I, like Steve, have a petroleum background. Routinely in petroleum coiled tubing is better for hole stability because you are continuously circulating. You're not stopping circulation to change rods, so the cuttings don't go down to the bottom of the hole and bog up the rods. There are a number of challenges to taking coil tubing from petroleum to minerals. They were largely increasing the life of the coil. We have taken the life of the coil from 30 trips in and out the hole to 1,000 trips in and out the hole by a bunch of different things. That's absolutely critical for the cost model. There is a video there, I'm not going to play it because I don't have time, but if I let that play for 2 minutes, it would drill 0.8 of a meter, and that would be 24 meters per hour, but I haven't got time to do it. I may see if the AV gentleman can play this. Can you click on that? It might turn on its side. Sometimes does that. No, so here we are. That's tripping in and out the hole. So that goes for about a minute. I'll let it play for its minute. I think the radius of the coil there is about 9 meters. So in watching that for 1 minute, there's 2 revolutions of the coil, so it's 18 meters of tripping in. So 18 meters of tripping in 1 minute means you're tripping in 1,100 meters per hour. Think of changing a rod at 500, changing a bit at 500 meters and all those connections that you traditionally have to make. That really is, you have to go out in the field and you have to see that happening with no one touching the drill string, no one near the drill string, and us getting to the bottom of a 500-meter hole in about 25 minutes and starting drilling again. It is truly revolutionary. That's how things are going to be done 6 times cheaper. I will just bump on rather than let go right through, because I just want to summarize, really, because the coiled tubing is the new bit. These are the advantages. I've said them before. We've done a couple of field trials, so we've drilled only in 3 environments. We'd love to have drilled in thousands and thousands of hours in the clock, and that will happen. But we were trying to take things to working prototype. We have run the coiled tubing rig very successfully in 3 different environments. Our drilling laboratory at Bracunga, Cambrian, green schist facies, shales and sands. This Port Augusta trial that's up on the screen, really quite hard indurated cover, including quartzites. And there's some of the key stats up there that hopefully you can read as I'm talking. We addressed the kind of challenges people were worried about. Could we drill a straight vertical hole? Could we drill hard rocks? Would the coiled tube last? And also a key one, a lot of our effort has been how representative is the sample. This is a direct circulation method, fluid down the center of the pipe, cuttings up the annulus. You've got, I can't even remember the colors, but one of those colors is core 50 centimeter core assays. One of those colors is the cuttings from the coiled tubing, and very well resolved is a less than 1 meter copper enriched zone at 400 meters depth. There is a lot of water going through the system, and the cuttings are coming through pretty quickly. So in fact, the challenge is almost not so much the representativity of the cuttings, it's dewatering and preparing them for analysis. We have also drilled at Horsham. Really interesting case. This is quite different from Port Augusta. Very unconsolidated, running sands. Lots of holes unsuccessful in this environment. We were through about 140 meters. For those who know this area, it's the Loxton Perilla running sands, sub-freezing temperatures as opposed to the 40-degree temperatures. And there are stats there as to what we managed. We're still learning. We've only drilled in 3 environments. There is room for improvement in tuning the downhole motors and bearing packs and elastomer seals. We're learning there. We're also learning in terms of the fluid system. Interesting, there's also not a big step for this rig to core. A lot of our experimentation was with a diamond bit. So given you can trip in and out so quickly, if you did have something particularly interesting, we will be able to trip out, put on a coring barrel and a coring bit, and cut a stick of core. But you would have to trip in and out for each stick of core because it's not a wireline recovery system. I'm just looking at Rob to see if I've got a minute. That's, didn't need you to tell me. Look, a simple point. Those are pretty impressive results. I didn't bother reading the numbers, but 100 meters a shift compared to 25 meters a shift at the first time of trying something that is really, really different. That's how long diamond drilling's been evolving for. That coiled tubing ROI actually had to double. The first half from 2006 to 2011 was just getting the money together to do it. So we have developed coiled tubing for less than that. So to have these kind of results, I think the future is exciting. And back to prospecting drilling, if we can take a lot of samples, if we know how elements are transported and comported in the subsurface, we can make discoveries. It's very hard to make discoveries with a minuscule sampling of one drill hole on a geophysical anomaly. And we can use vectors. There's been so many vectors shown in this conference. I don't really need to show another one. That's one of our key ones, antimony around the Western Australian goldfields. And together we think these technologies will enable prospecting drilling. So thanks very much.
Any questions for Richard?
Can you describe details of how the drilling takes place?
Sure. So I don't know how details you want the details, but obviously you can't rotate from the surface. So at the basic level, you can't rotate an entire coiled tubing. So the drilling is all by downhole motors. So the critical part is the bottom hole assembly. So you obviously have a pivot point at the point of the tubing. Our drilling in hard rocks is by percussion. So we have a pressure displacement motor and a water hammer, and that drives a percussion bit. But we also have turbines for high-speed rotary. A key point is there's relatively low weight on bit. It's only 100 to 200 kilos on the bit, whereas you would conventionally have tons, 1 or 2 tons on the bit in diamond drilling. So if you're going to drill in a rotary or diamond way, you've got to rotate very fast. Percussion doesn't need a lot of weight on the bit. You would only have 100, 200 kilos weight on the bit anyway in percussion. So downhole motors, percussion for hard rocks. For soft rocks, we just use a blade bit, again, with a downhole motor. Is that the kind of things you're interested in?
And how do the samples come out? Is this the mud or this is a...
Yeah, they're coming out of the mud. So the mud is being circulated inside the drill pipe, and it's coming. All the samples are coming up the annulus with the mud and being separated with the solids removal unit. Thanks for those questions.
So when you're rotating, not hammering, are these typical PDC bits like the oil patch?
Yeah, so when we've done more percussion, and the percussion bits look pretty much like normal percussion. When we're rotating, a whole variety of bits. We've used PDC, we've used blade bits for soft rock, but we also use like a full face diamond bit as well. So really depends on the lithology you're working with.
Will that be available to other people?
Yeah.
Or only through Board, Longyear and the other?
That's a really good question. So the technologies I mentioned before have been licensed. We have just offered our coiled tubing rig for licensing because we take things to a working prototype, then we license to our sponsors. So the companies with the first right to bid on the coiled tubing rig are Imdex, who are one of our partners, and Board Longyear. And right now we've just made that offer to them, and they're contemplating what they wish to do. So there'll be more news in that space in just a few months. Yes, so as it stands here, we're using gravity a bit, so 60 degrees or 30 degrees off vertical. Look, a really important point, and Steve mentioned the Numinix CRC bid. Coiled tubing, of course, has the potential to drill long horizontal legs. We never tried to put geosteering on this coiled tubing rig. We were trying to solve 3 challenges. Could it be cheap enough with coiled durability? Could we drill hard rocks with low weight on bit? And could we get a reliable sample? They were our kind of walk before you run coiled tubing challenges. And that's what we think we need for exploration. But we see this, if you give it geosteering and use the bent sub at the top of the assembly, we see it as a terrific tool for drilling out. But we haven't developed that yet. Just 60 degrees, 30 degrees off vertical with this rig.